boys and girls. It's Miss Manning. Today I'm going to be teaching you Module 4, Lesson 5, where we're learning to connect the visual models and the distributive property to partial products of the standard algorithm without renaming them. So basically, what that's saying we're going to do is we're going to be learning this method called the area model. And for us to do the area model, we have to distribute or remember that means to break apart some of our numbers. And we're going to take that area model and we're going to connect it to basically what you're doing when you solve it the standard way that we think of, and connecting the area model to those partial products that you get when you're multiplying multi-digit numbers. So for us to do this, for us to do the area model, what we have to do is we have to distribute or break apart the factors. So if we get a problem like 23 times 12, we're going to have to pick one of these two factors to break apart. And then we are going to label it as part of our area model. I did that one wrong. Sorry about that. So if I kept 23 the same, but I separated 10 and 2 to make 12, then I'm going to try to think of this as an area problem, which when we're finding the area of a space, we're taking the length times the width. So in this case, it would be 23 times 10. And then down here, this rectangle right here has a length of 23 and a width of 2. So right now, what I've just ended up with, I'm going to have two partial products, part of the product of 23 and 12. When I'm done with that, I have to take those two partial products that I get and I have to add them back together. I have to put it back together for me to end up finding the correct answer. But what we are trying to do is relate it to this idea of the traditional multiplication, which would be this. And in this problem, if you look at it, what I'm actually doing is I'm taking 23 times 2. First, I start with 3 times 2 and I get 6, 2 times 2 and I get 4. So 23 times 2, which is the first step of my standard multiplication, is basically what I'm doing right here. So I'm going to end up getting the exact same answer here. Then we go down to our next step, which I always tell my kids we put a placeholder 0 because we're not multiplying it by 1. We're actually multiplying it by that 1 in the tens place, which makes it a 10. So if I'm multiplying something by 10, my answer automatically always has a 0 at the end. So I'm taking 23 times 10, which is what we're doing right here. And so I would get 230, which is what I also get here. So 230 and 46 I have to put back together, which is exactly what we do in the standard algorithm of placing our numbers back together, our partial products back together, when I add them together to get the product of 23 and 12. So as long as you're breaking apart your factors and then you're multiplying them, thinking of the area model, and then you add your partial products, it doesn't matter if you're using the area model or the standard algorithm, you're doing the exact same steps. Let's get started with an application problem for today. Anisha is setting up a play space for her new puppy. She will be building a fence around part of her yard that measures 29 feet by 12 feet. And it says, how many square feet of play space will her new puppy have? So it's asking for square feet. So actually, what they want is the area in between. They kind of trick you a little bit by saying it's 29 by 12 by talking about a fence, which leads my brain immediately to a perimeter question. But then it asks for the square feet of play space. So it actually wants the area in here. So let's go ahead and jump into that area model first. So what we need to do is we need to break apart one of our numbers. Let's break apart 12. So I'm going to break it apart into 2 and to 10. So I've distributed that 12. It's kind of like a number bond here. And eventually I will put those partial products back together, but I first have to multiply them. So now we do the area model. We do area equals the length of this rectangle times the width. Because if you think of this rectangle, it's 29 by 2. So 29 times 2, I'm going to think of that as 30 times 2. But the difference between 29 times 2 and 30 times 2 is that extra 2, that extra um, uh, copy of 2 that I'm adding to it. So I need to then take away 2. So 30 times 2 is 60, minus 2 is 58. So here I've done 29 times 2 equals 58. Then here I've got to think of the length of this rectangle as 29, and the width of this rectangle is 10. So 29 times 10 is 290. So I have two partial products here. Now I've got to take my partial products, 58 and 290, and my third step is to put them back together. So 8 and 0 make 8, 5 and 9 make 14, and 1 and 2 make 3. So this puppy ends up with 348 square feet of play space. So for our lesson today, I told you that we're doing this area model. They've already taken our problem 21 times 5, and they've split it up for us so we can get some partial products. The way that I want you to think about it is this is the area model, but there are other ways to look at this. There would be like a tape diagram, which says right here we're making 5 copies of 1. So let's draw this like a tape diagram and make 5 copies of 1. So in this, there are 5, which is what we would get with 1 times 5. We would get 5 units. But also, we would have 20 copies of 5. 6, 7, 8, 9, 10. Whew, so I have 20 there, and each one of those would have 5. So I would have to keep repeating that. Or I could think of one row of these equaling 5, like I did in this previous one. Ooh, but I'd have to make 20 of those, and I just don't have the space to do that. So it's kind of a messier way, but essentially you're getting the same thing. We're just, instead of drawing with pictures, we're using our numbers to really show what we're doing in that problem. We're using our multiplication sentences to say, well, the length of this one is 5, the width is 1, so I'm going to take 1 times 5. My partial product is 5. The length of this one is 5, the width is 20, so I'm taking 20 times 5, and my partial product is 100. Now what I've got to do, since I've distributed, I've broken apart this 21, I need to take those two partial products and put them back together. I have to add my partial products back together. So what I'm really talking about is the difference between this and this. So we have the area model here, and we have the tape diagram model here. And I love tape diagrams for most problems, especially word problems. But in this case, the tape diagrams tend to be a lot more for your brain to kind of take in. Usually the visual representation really helps my brain wrap around the math of it. But in this case, the simpler version is what's helpful. The way that they're similar is this first part here and this first part here. The partial products are 5. And down here, 20 times 5, what I would really have, 25s, what I would really have in this bottom box here, 25s, I would end up with the same partial product of 100. So in that sense, they are similar. They are the exact same representation. They're just done in ways where this is more with the numerical and this is more with pictures. And that's fine if we end up with smaller numbers. But when our partial product's 100, there's no way that you can make 100 boxes here or even 20 rows here. You just run out of space and you end up wasting time doing that. So we're really going to stick with this area model here and leave the tape diagrams for our word problems. So let's go ahead and practice with 23 times 31. So first they want us to estimate what this would be. So I'm going to round 23 to 20, and I'm going to round 31 to 30. So right here I have the basic fact of 2 times 3, which is 6, and then I have 2 zeros to add. 1, 2. So I should end up with a number around 600. So let's go ahead and let's distribute our factors. I'm going to distribute 31. So I'm going to label 1 and 30. And I'm going to keep 23 together just so I can relate it to that standard algorithm. You can end up breaking it apart into 20 and 30, but what you do is you end up having, let's see if I can draw it real fast. You end up having to do 4 partial products together instead of just 2. So it's not that you can't do it that way. If you need to do it that way, you are more than welcome to. We're just trying to eliminate the number of opportunities for a mistake. So here I have a length of 23 and a width of 1. So I have 23 times 1, which gives me a partial product of 23. Here I have a partial length, of 23 and a width of 30. So what I can do is I can take 23 times 3, which equals 69. And then I have my 0 here, so 690. So I've done my area, my length times my width. Now I have to add my partial products back together. So I have my ones place, which is 3 and 0, 3. I have my tens place, 9, 10, 11. Carry my 1, and I have 7, 713. Now let's compare that to our standard algorithm. So I'm going to write 21 times 31. Yep. Nope, not 21, 23. That would have given me a different answer for sure. So first we're going to go ahead and we're going to do 23 times 1. That's what's going to be in this first row here. So I have 3 times 1 is 3. 2 times 1 is 2. Same partial product. Now I'm going to do the 23 times 3, or actually 30. So I put my placeholder 0 here, and I do 3 times 3, which is 9, 2 times 3, which is 6. So I get 690, which is the same partial product that I got here in the area model. And now I'm going to go ahead and I'm going to add them all together. Add my partial products, 3, 9, 10, 11, 6, 7. So I end up with the same answer, or the same product, I should say. 23 times 31 is 713. All right, that's all I have for you guys today. I'll hope to see you again soon. Bye.